What if your fingertips had taste buds? You wake up, you blindly slap your hand down on your nightstand to silence your phone alarm. Instantly, you taste warm glass, oily fingerprints, and the distinct metallic tang of the bathroom floor from when you dropped it yesterday. Welcome to your new reality. To understand the sheer horror of this existence, we have to look at what a taste bud actually is. They aren't just little flavor sponges. They are bundles of specialized epithelial cells packed into onion-shaped clusters inside those tiny bumps on your tongue called papillae. At the very top of each bud is a microscopic pore. But here is the biological catch. For you to taste anything, the food molecules must be dissolved in a liquid so they can wash down into that pore and bind to your chemoreceptors. On your tongue, that liquid is saliva. On your hands, it would have to be sweat. Your palms are already packed with eccrine sweat glands, so congratulations. Your fingers are now self-lubricating flavor vacuums, constantly dissolving the chemical profile of everything you touch and firing those signals straight up your median nerve to your gustatory cortex. Let's do the math on the volume of sensory input you are about to deal with. A standard human tongue has an average surface area of about 40 square centimeters and holds roughly 10,000 taste buds. That's 250 taste buds per square centimeter. The average index fingertip is about 2 square centimeters. If your fingers evolved the same receptor density as your tongue, you are looking at 500 taste buds per fingertip. Across all 10 fingers, that is 5,000 microscopic mouths dragging across the world every single day, increasing your brain's flavor processing load by 50%. Every mundane task is now a culinary event. Typing an email, you are tasting the dead skin cells, the coffee spills, and the sneeze droplets of everyone who has ever touched that keyboard. Pushing a shopping cart, you're tasting a rich umami blend of rust and toddler spit. You'd reach for a public doorknob and immediately get a sharp hit of bitter brass and salty grime. Petting your dog would be delicious, assuming you like the taste of dander and whatever they just rolled in on the lawn. Preparing food would be uniquely awful. Chopping jalapenos wouldn't just risk burning your eyes later. The capsaicin would instantly trigger the pain receptors on your fingers, setting your hands on fire the moment you slice the pepper. On the bright side, you could season a soup just by dipping your thumb in the pot to see if it needed more salt. But don't even get me started on going to the bathroom. You will learn very quickly why toilet paper thickness is suddenly the most important metric in your life. You'd have to wear gloves constantly. Gloves would become the new underwear. You'd have casual gloves, formal gloves, and latex eating gloves for when you want to enjoy a hamburger without tasting the paper wrapper. If you took your gloves off in public to grab a subway pole, people would look at you like you just licked the pole, because chemically speaking, you just did. So why didn't we evolve this way? It's not a biological impossibility. Houseflies and butterflies have chemosensory hairs on their tarsi, which are their feet. When a fly lands on your sandwich, it is tasting the bread just by standing on it. But flies eat decaying matter, and their entire survival strategy is based on finding rot as fast as possible. You are a large primate. You need thousands of calories a day, mostly from complex plants and cooked meat. If you tasted everything you touched, the sensory overload would paralyze you. Your brain reserves its high-definition chemical analysis for the final checkpoint before digestion. Your mouth is an evolutionary bouncer, checking IDs right at the door of your gastrointestinal tract to make sure you aren't eating poison. So, be grateful your fingers are strictly tactile. Be glad you can hold a handful of loose change without tasting the copper, zinc, and 100 strangers' pocket lint. But before you get too comfortable in your flavor-proof skin, you should know something about how human genetics actually works. The genes that code for the taste receptors on your tongue are surprisingly active elsewhere. Scientists have found fully functional sweet, bitter, and umami receptors in the human airway, in the lining of the stomach, and in the pancreas. They don't send signals to the conscious flavor processing part of your brain, but they are chemically tasting your internal environment right now. Oh, and one more place. In 2013, researchers discovered that the highest concentration of sweet and umami taste receptors outside the mouth is actually located in human testicles. So your fingertips might be safe, but depending on your anatomy, you are already tasting your underwear.